Hi, my name is Mr. D, and today I want to take a look at using integration to find the area between two curves. So we have find the area between the curves y equals 12 minus x squared and y equals x squared minus 6. So the first thing we should do with this problem is get a visual of what these two curves look like. So we draw our xy axis, and we notice that the first parabola, 12 minus x squared, crosses the y-axis at 12, and since we have a negative x squared, this parabola is going to be opening downwards. So for the second equation, we have y equals x squared minus 6. So this parabola has a y-intercept of negative 6, and since it has a positive x squared, this parabola is going to be opening upwards. So this picture is just supposed to give us a rough idea of what's going on, but more importantly, it's going to help us set up our integral so that we can find the area between these two curves. So what we're trying to find is this section here that I'm coloring in. This is what we mean when we're saying the area between these two curves. But in order to set up an integral, we need a lower and upper limit. And to find the lower and upper limit, we need to just find where these two curves intersect, the beginning and the end. So the way that we're going to find these two intersection points is we're going to set these equations equal to each other. So we're solving 12 minus x squared equals x squared minus 6. We just need to solve this equation for x. So we could add x squared to both sides, and we could also add 6 to both sides. On the left-hand side, we're left with 18. And on the right-hand side, we're left with 2x squared. So now we just need to divide both sides by 2. And we're left with x squared equals 9. So we take the square root of both sides, and we have x is equal to plus or minus 3. So this tells us that the points of intersection occur when x equals negative 3 and when x equals positive 3. So now what this is going to help us do is now we can set up our integral. But remember, in general, when we're finding the area between two curves, we set up the integral from a to b. This represents the first intersection point and the second intersection point that kind of encases the two curves to give us this area. So we're setting up the integral from a to b of the absolute value of f of x minus the absolute value of g of x. And all these functions represent are the two curves involved in generating this enclosed region. But to make life easier, I promise you, you're going to want to choose f of x to be the greater function. And what we mean by the greater function is the function that's above the other. So in this case, we're going to choose f of x to be this function on top, which in this case is 12 minus x squared. And the function on bottom in this case was x squared minus 6. So we could choose, and remember now the integral is, in our case, is going to go from negative 3 to 3. Remember, this is sort of like the beginning and end of the enclosed region. And now f of x, we chose it to be 12 minus x squared, and we're subtracting g of x, which in this case is going to be x squared minus 6. Remember, it doesn't matter which one you choose to be f or g of x, but it makes life easier if you choose f of x to be the greater function. That way you don't have to account for any sign changes. So what we're going to do in the next step, we have the integral from negative 3 to 3, and we're looking at the absolute value of 12 minus negative 6 is a positive 18, and we have negative x squared minus x squared is a negative 2x squared. So you have negative 2x squared plus 18 inside of our absolute value bars, dx. And one thing you could quickly check, notice that negative 2x squared plus 18, this expression is always greater than or equal to 0 when we're between negative 3 and 3. So that was the purpose of choosing f of x to be the greater function, because now we could just simply rewrite this as the integral from negative 3 to 3 of negative 2x squared plus 18. Remember, based on the definition of absolute value, if the expression on the inside is greater than or equal to 0, you just rewrite that expression. So once again, that's why we chose f of x to be the greater function, because it makes taking the absolute value a lot easier. So now at this step, we could go ahead and find the antiderivative of this expression. So we're looking at negative 2 x to the 2 plus 1, so to the third power, and now we just divide by 3. We're just using the power rule for integration. And now we have plus 18x to the first, but we don't need to divide by 1 because that's a trivial result. And we're evaluating this from 3 to negative 3. So now we're just going to substitute. We substitute the upper limit first. So we're looking at negative 2/3 times 3 to the third power plus 18 times 3. That's the result of plugging in our upper limit, and we're subtracting the result of plugging in our lower limit. So we have negative 2/3 times negative 3 to the third power plus 18 times negative 3. So now we just have to simplify. 3 to the third power times negative 2/3. The result of this is going to give us a negative 18. Plus 18 times 3 is 54. And now we're subtracting negative 2/3 times negative 3 to the third power is a positive 18. And now 18 times negative 3 is negative 54. So now to simplify, we could do negative 18 minus 18 is a negative 36. 54 minus negative 54 is a positive 108. So now all we need to do is just add these two numbers together. Negative 36 plus 108, which we'll just write under it, is a positive 72. And this is going to be our final answer. The area between the two curves that we just sketched, we work this all out and we'll find that the area between the two curves is 72 square units. Okay, well this is going to conclude this video on using integration to find the area between two curves. Thank you all for watching, and I hope that this was helpful.